Hello everybody, this is Grant, your friendly neighborhood InstructLab community member. In this video, I want to show you how to use the InstructLab project on Windows. I often get asked this question, and the answer is yes, you can indeed do this using the Windows subsystem for Linux. I am not going to cover how to install the Windows subsystem for Linux. I will leave you to Google that on your own. But this will allow you to get InstructLab working with Nvidia CUDA support if you have an Nvidia GeForce driver. So let me open a new command prompt and make this font a little bit bigger for you. It has been a very long time since I have used Windows and WSL. And I normally just use Windows for gaming, and even then I just use Linux for the most part nowadays. So I'm going to install a new Ubuntu box. I realize that I normally and always actually prefer Fedora, but I do recognize a lot of you are going to be using Ubuntu, so I thought I would show you how to do that. So I'm just going to install a new Ubuntu WSL environment and create a username and password, and it is going to get that virtual machine running, and now I am in it. So let's open up an Ubuntu terminal so we can take advantage of the nice color space here. All right, so it has been a very long time since I have used Ubuntu, so bear with me if I use DNF instead of apt-get a lot of times. Let's check our Python 3 version, and of course it's Python 3.10.12. I want a newer version. Thanks a lot, Ubuntu. So I didn't actually know how to do this. It is very complicated on Ubuntu. So I Googled real quick how to install Python on Ubuntu, and let's do this and see if it works. Let me go back to my terminal, paste this in, and this will do some stuff, and then it's going to make us install a third-party PPA, oddly enough. Thanks a lot. So let's install this PPA to pull packages from somewhere else. And then I believe we should be able to do sudo apt-get. Maybe do we need to do update first? I don't know. Let's do sudo apt-get install Python 3.11. Yes, we do want to install that. Now if we do Python 3.11 -- version 3.11.9, perfect. Okay, now let's make a new directory called demo, and let's create a virtual environment. This is what the instructions for InstructLab tell you to do. Let's see, Python 3.11 command, ensure pip upgrade. Why can I not just create a virtual environment here? -m vmv. Did I type it wrong? No. pwd. Oh, I need to be in the demo directory. Okay, now let's try it. No, still same thing. What is going on here? Why is this not working? Python 3.11 -m. What does that do? Okay, and we want to create a VMV and then a VMV. Python 3. Let's just try that. Yeah, that seems to be working. Let's do pip 3. Do we have pip 3? Let's do sudo apt install Python 3 -pip. Oh, I know what we need to do. We need to install the VMV plugin for Python 3.11. So give me a minute here. Let's get pip 3 installed first. 5 minutes. Give me a break. Give me a faster mirror here. Here we go. This is looking better. Alright, now we can do sudo apt-get install Python 3.11 VMV. Okay, now we can do this. Better be able to. Anyway, sorry, again, it's been an extremely long time since I've used Canonical. So now let's source this directory, vmv bin activate, and let's simply do a pip3 install InstructLab. And this will download the InstructLab command line tools and compile everything. What is fascinating about this process is that it will also include CUDA driver support. Assuming that you have an Nvidia RTX card installed and available on Windows, it will pass through that graphics card to your WSL environment, and the InstructLab is already picking that up. You can see it downloading and compiling the CUDA driver support for InstructLab and PyTorch, which is pretty fantastic. So we will let this finish, and then we will start, we'll verify that it is using the Nvidia card for GPU acceleration on the train and generate and serve and other things. Shellingham, all right, let's see if we can build the Llama CPP Python at this point. All right, so everything should be installed and it should be cleaning up now. It is just installing the collected packages inside of that virtual environment for us inside of this WSL2 environment. So we'll let this finish up, and then let's install NVTop, download a model, serve it, and we will be able to see that it is indeed using that. So I'm going to go ahead and preemptively open a new terminal and do sudo apt-get install NVTop. And let me authenticate to get this installed, and let's run NVTop. And so this will let us know how much of the GPU is being used. So let's go back over here. Now let's do an iLab init, and this will get our iLab configuration set up. Let's download a model and serve it. And this is going to download the default Merlinite model. It's about 4.5 gigs in size, so it should take about 40-50 seconds here on a gigabit internet connection. It is going a little slow, 80-90 megs a second. I generally get 110 or something like that. So it'll take just a little bit. Let's go back over and look at our NVTop. Now this is running in Ubuntu, so you can see that it is displaying the GPU being used, and that's probably due to my screen recording that I have going on, because again, this is shared between Windows and Linux. You can see that I'm using 3.7 gigs of the 24 gigs on my GPU. All right, so that file has been downloaded. Let's just start serving this with ilab serve -- model family Merlinite and -- model path, and let's pass in models and then Merlinite, and this will begin to load that model into memory, and will then begin to serve that model as well. So let's open up yet another terminal and make this bigger. Oops. And let's go into our demo directory, Python 3.11. Oh, sorry. Let's source the environment first, then activate. And then let's iLab chat, just -- model family, Merlinite -m, and models Merlinite. And let's say, hello, how are you today? And it will chat with the model and return an answer. We can see the spike there. Let's do one other cool trick here. Let's exit this and let's do iLab sysinfo. And this will let us know some interesting stuff. What I wanted to highlight here is PyTorch is indeed using CUDA. Torch backend's CUDA is built as true. So this is pretty awesome. Here's the CUDA 0 device name. It is a GeForce RTX 4090. All right, kids, that's all there is for today. I hope you found this video useful. It is very easy to get it set up with InstructLab inside of the WSL2 environments. I would suggest you use the Fedora environment, but if you want to use Ubuntu, go ahead. But Windows will pass through the GPU for you. One other thing to note, in order to use WSL2 or WSL, Windows Subsystem for Linux, on Windows, you do need a Windows Professional license. Don't know why that is. I guess using Linux is a professional feature, so you will need to get that. All right, thanks everybody.